एमएस मॉडल स्कूल ऑनलाइन क्लासेस में आपका स्वागत है। आइए नेक्स्ट वीडियो में हम रेशनल नंबर्स के और रिजल्ट्स के बारे में जानें। इस वीडियो में कुछ क्वेश्चंस को सॉल्व करने से पहले हम पिछले वीडियो में पढ़ी हुई कुछ बातों को याद करेंगे। सबसे पहले हमें ये 2-3 चीज़ें यहाँ बहुत सीरियसली पढ़नी होंगी। और पहला रिजल्ट है कि यदि दो रेशनल नंबर्स के बीच में हम कोई भी ऑपरेशन करते हैं, ऑपरेशन मीन्स एडिशन, सब्ट्रैक्शन, मल्टीप्लिकेशन एंड डिवीजन। यदि एक रेशनल नंबर दूसरे रेशनल नंबर में जोड़ दिया जाए तो आपका रिजल्ट रेशनल नंबर रहता है। एग्जाम्पल के लिए यदि हम 1/2 प्लस 1/3 को ऐड करें, both are rational numbers, then you will get a rational number. Taking LCM 6, 3 plus 2, it will be 5/6. So here in this result, we will use it later on to prove next questions. I am repeating, if rational numbers are operated within themselves, the result is always rational numbers. Next topic. A rational number can never be equal to an irrational number. We have proved, just like under root 2 was non-terminating, non-repeating decimal 1.414 and so on. You might have seen value of 5. These numbers cannot be expressed in form of P upon Q. This is an irrational number. It is not equal to any form of P upon Q where P and Q are integers and Q should not be equal to 0. This is definition of rational number. In previous video, I have proved that under root 2, under root 3, under root 5, under root 7 and under root 11, all these are irrational numbers. You might have watched the previous video. If not, kindly go through it. We have proved all these sums. We have proved under root 2 is an irrational number by method of contradiction. I have told you what is method of contradiction. Let me remind once again. If I am taking pair of lines in a plane and someone says these two lines are not parallel, then I can confirm that these are intersecting lines, as there are only two possibilities. In this case, if I say this M and N are not intersecting lines, means this line M is parallel to N. This is method of contradiction. Let this line be, I am repeating once again, this line P, this line Q. If P and Q are not parallel, means they are intersecting. If line M and N are not intersecting lines, means these are parallel. Taking proof for next, I will use all these three facts. Earlier I have proved that only if there is case of under root 5, then we have seen that under root 5 irrational number था. It cannot be represented in form of P upon Q. So I'm taking the result directly. Now I should not prove it again. मुझे अब ये दोबारा से सॉल्व नहीं करना है. सिर्फ इतना यूज करूंगा कि √5 इरेशनल नंबर था. हमने ये थ्योरम में सिद्ध कर लिया था. आई एम टेकिंग 3 + 2 √5 is irrational number, and later on I will find out whether these numbers are rational numbers or irrational numbers. You have to prove them all. I am taking proofs. 3 + 2 √5. Creating space. Let's try to solve it here in this area. Let this number 3 + 2 √5 be some rational number equal to some rational number a upon b, where a and b are integers and b is not equal to 0. You must learn the condition a and b are integers and b is not equal to 0. If I take this 3 here, what will you get? 2 √5 is equal to a upon b minus 3. Take LCM. 2 √5 is equal to b LCM a minus 3b. Divide both sides by 2. √5 is equal to a minus 3b upon 2b. If a and b are integers, then this number is again rational number. So you have to state a minus 3b upon 2b is a rational number, and on the other hand √5 is an irrational number. Earlier I have told you in effect that a rational number cannot be or is not equal to irrational number. So therefore this is a contradiction. If it is a contradiction, it occurs due to wrong supposition. Therefore, our earlier supposition was wrong. This number was a rational number. Therefore, 3 + 2 √5 is an irrational number. I'm taking next by the same method. Once again, let. I'm taking same method. Let a upon √2 is some is equal to some rational number a upon b. You must write the condition here where a and b are integers and b should not be equal to 0. Multiply them both sides or get its reciprocal. Taking reciprocal on both sides, under root 2 will be equal to b by a. Here you should write one more condition that a should not be equal to 0. Now b and a are integers and a is not equal to 0. This is the form of rational number. Here b upon a is a rational number, but under root 2 is an irrational number. We have proved it earlier. That's why there is a contradiction. Our supposition was wrong, that it was a rational number. Therefore, we can prove this sum in this method. This sum can also be proved by taking same method. I am giving hints. Let 7 under root 5 be sum equal to some rational number a upon b. Dividing by 7 on both sides, you will get under root 5 is equal to a upon 7b. Clearly, a and b are integers and this is a rational number. So now the contradiction arises that irrational number has become equal to rational number. Due to this contradiction, we arrived on the conclusion that 7 under root 5 was irrational, and this sum can be attempted in the same manner. I am taking one more example for you. All these are simple. Based on theorem, prove that under root 2, under root 3 are irrational numbers. I am taking this example once again. Let under root 3 plus under root 2 is equal to a upon b, where a and b are integers and b is not equal to 0. Taking square of this, squaring on both sides, what will you get here? You have to apply a plus b whole square formula. Under root 3 square is 3, under root 2 square is 2, 2 times the product. It is 2 under root 6 is equal to a square upon b square. What will you get in next line? 2 under root 6 will be equal to a square upon b square minus 5 upon 1. Simplify this. I am simplifying it. 2 under root 6 is equal to, take b square as LCM, it will be a square minus 5b square divided by 2. So you will get under root 6 is equal to a square minus 5b square upon 2b square. Here this contradiction arises once again. I am writing it in expanded form so that you can understand it clearly. Here comes this statement, a square minus 5b square upon 2b square. I have written a statement earlier that if rational numbers are operated within them, means A, B were integers, and this combination of all these A and B will give you a rational number is equal to a rational number, as A and B are integers and B is not equal to 0. So it will provide you P upon Q4. On the other hand, under root 6 is an irrational number. In second statement, I have told you that a rational number cannot be equal to an irrational number. Therefore, our supposition was wrong. If our supposition was wrong, what was our supposition? That under root 3 plus under root 2 is equal to A upon B. Therefore, under root 3 plus under root 2 is an irrational number. You have to go through such more examples in papers. Such type of questions are frequently asked. In next video, I will solve some of the questions that appeared in examination this year, which are of the same type. Thank you for watching this video. I hope you will understand it. If not, kindly contact me.